Chapter 5, Question 1. Okay, so a 6.0 kilogram box is held at rest by two ropes that form 30-degree angles with the vertical. An external force F acts vertically downward on the box. The force exerted by each of the two ropes is denoted by T, which I put here, T. A force diagram shows that the four forces that act on the box is in equilibrium. The magnitude of the force, so given, the magnitude of the force is 410 newtons. The magnitude of the force T is closest to what? So we are given the box equals 6.0, where's two ropes, 30 degrees each. Okay, so we have W equal magnitude times gravity, which we know gravity is 9.8. We like to go like this just to round it up. So now we do 6.0 kilograms times 10 m, which equals 60 newtons. Okay, so we take this equation right here and we go the sum of force Y equals work plus force A minus T. So we do MA equals work plus force A minus 2T, because we just combined the two T's. So we know that MA equals 0, which is work plus force A minus 2T. So when we remember, this is cosine, right? So with that, we take the 2T cosine of 30, which equals the 6 times 9.8 or 10, whatever you prefer, plus 410. And how do we get 410? We know that T, so say this is our box, 6.0. We know that force is downward. T. Oops, that was wrong. Let's rewind. Go like this. Make it better. 30. This is T, 2T. So we know that 6 times gravity plus 410 newtons. So we take this number and times it, and you'll get 58.8 plus 410, which would get you 2t cosine of 30 equals 468.8 equals 470. 470 newtons over 2 cosine of 30 degrees equals 271.3546. The answer would be 271 newtons.